So once again, welcome to day 5, the final day of this Huawei and Communications Authority Cybersecurity Bootcamp. For those who've been wondering who I am, my name is Kevin Tui, and I'm one of the instructors taking participants through the HCIA security content, as well as preparation for the certification exam. So today we're going to be looking at some content from module 4 and 5. So in terms of module 4 is all about the applications of encryption and decryption, which is very important because even when you're going through even some challenges, for example, like competitions that are CTF competitions, capture the flag, there's some things about cryptography and the concepts around it that you really need to understand, and so that you can be able to tackle those challenges. And it always stems from the theory before you get to the practical. So you cannot do anything on the practical if you haven't done the theory. Even those who started, if for those who have ever done driving, you actually have to drive like a small car on the town board before you go out there and start driving a real car in front of people. So the theory is very important, because before you get to if you try to skip that, you'll be up for a road shock when you start dealing with items. You'll realize that you really have to go back to your books and research what you haven't learned. So let's get to it. So the first item within this application of encryption and decryption is encryption and decryption mechanisms. So which are they? So we realize this. You realize that, let me get my pointer. You realize that there's something called data encapsulation, right? We've talked about these over the last few days, where as packets are being transmitted through the stack, for example, like the TCP/IP stack, they are encapsulated. Then when they get to the sender, to the receiver, I mean, they are actually decapsulated. So you realize this, that data that is encapsulated based on what the TCP/IP stack, we talked about the TCP/IP and the OSI model, they're usually transmitted in plain text over the internet. So the keyword here is plain text, which you're going to see, which actually results in some risks, such that, for example, passwords can be leaked, bank account information, credit card information, impersonation can take place. And when you look at this, there's a solution to it. So when encryption and decryption technologies came into the flow of the technology industry, and they started being applied on the network, the data being transmitted through the protocol stack, the TCP/IP stack, was now protected, and there was a huge reduction with regards to the amount of information that could potentially be leaked. So when you look at this course, we look at how encryption and decryption technologies have developed over time. We're also going to look at the processes that occur, although we're not going to look at it in much detail, as would be in the slides, I'm sure of that. Then we're also going to understand the mechanisms that are there within encryption and decryption algorithms. And even as we do that, remember that there are some things that are very important. For example, data structures are also key. Getting to understand key computing algorithms, that will make you stand above the rest, because when you understand the algorithms or whatever is really going on behind a protocol or behind a security strategy, you'll now have that confidence of building tools or actually configuring tools with that background knowledge or that foundational knowledge with you. So let's go on. So let's look at the development of encryption technology. So let's look at cryptography. We already know that this is even usually a topic within like, or an area of interest, or a topic within a challenge, for example, like a CTF. So what we call cryptography is simply the conversion of what we call the plain text, which is what we can make sense of, and that requires to be hidden, to become what we call ciphertext, which is something that we cannot really understand by looking at it. And the key word here is actually using mathematical methods. So we have the plain text, goes through a key with some mathematical methods. You can see the method, for example, you can see here, cryptography, the ciphertext is usually equal to the encryption function, which takes in the key as well as the plain text as the input. Then you get a result as a ciphertext. So what are the functions? As we mentioned earlier about the principles of information security, we've already mentioned about confidentiality, integrity, availability, although availability is not in this part of encryption, because encryption does not really result into a higher availability, but it actually helps with some of these principles, that is CI. Then the other A, which is not availability, is authenticity. Then you also have non-repudiation. So all these encryption technologies foster these principles. So when you're looking at this, how did it start? So we had what we call CITEL, although we're not going to go into a lot of detail. Then we went to what we call the Caesar cipher, the railfen cipher, and then you had what we call the cipher machine. So all these, it started way back. For example, even before Christ, 50 BC. Or what is the other way we say BC instead of using that term? I don't know what you usually use. What do you usually say? What is the other word for BC? For one who don't know. I know AD means Anto what? Domino, something. Apart from before, there's another way, because there's a way you can actually say it. Before, yes, BCE, before Common Era. Yes, Brian, you're true. And AD stands for what? Others usually say after the death of Christ, but AD I think has another way of looking at it. Anno Domino. Yes. And what does that really mean? I always ask myself. I hear there are some people who even say right now we are in the year what? 2015 or 20 what? The Ethiopian calendar what? So there's a BC. Latin word mean in the year of Christ. Oh, nice. Thanks, Major. You know, I learn a lot from you guys because you really engage a lot, and which is a very good thing. So there's a story here which is very interesting. I want to just tell you a bit. So during the First World War, Germany wrote codes based on a dictionary. So what they did is, for example, they used, for example, something like 10-4-2. So what they would do is they would have something like 10 or 2. So once they had that, that would mean what? The second word in the fourth paragraph on the 10th page is the paragraph. This one is a page, right? Don't worry, my handwriting is not that bad. When I start writing, I write better, but when you try to touch on the screen, it looks weird. So I'm even wondering, is that really me? But I think you're getting what this means. So the heads are what we call, and also in the Second World War, the most well-known cipher machine was what we call the Enigma. So it's very important to follow the history of things and see how they really moved. And it still was used by Germans to encrypt information. So they really are at the forefront of ensuring that they were there. So let's go on and see what is here. So let's look at the decryption mechanisms that were there. So this is very, very important. And that is why I don't want really to rush it. There's what we call symmetric encryption and asymmetric encryption. And when you move on, even when you start doing any other thing, for example, if you're a developer and you're dealing with encryption of data, you might deal with keys, SSH logins, usually deal with some key pairs, a public key and a private key. So you'll come to realize that these encryption technologies are here with us to stay. The only thing that is happening to them is that they are being strengthened further and further. So it doesn't mean that there'll come a time when they will disappear from the surface of the technology fabric. So when you start looking at some of the types of encryption technology, we have what we call symmetric encryption, which is a shared key. So means that the key is the same. The key is one and it is being shared between the sender and the receiver. Still the same key is the one that is used both for encryption and also for decryption. But in asymmetric, you realize that there's another keyword that is coming out here. It has to be different. And not about different is we have what we call a private key, and we also have another key called a public key. And the private key is used now for data protection. That is what it does. And the public key is used now by the users in the same system to check the validity of the information as well as its sender. So that is really what it is. And there's no worries when you lose a public key because it's actually most of the time available for public use. So you can say I've leaked a public key. So that is it. So this is the mechanism about it. So for example, for symmetric encryption, so they both use let's think of it that this one is user A and this one is user B. So they actually agree on and they negotiate on the symmetric key first. Then once they do that, user A will now use the symmetric key to encrypt. You can see the first thing is after this the data. So in the first step, it goes through the encryption process. The symmetric key is an input as well as the data. So this is where the process of encryption takes place. As an output on the third step, we now get what we call the ciphertext. Let me not write it. I don't want to have some weird handwriting there. So we have the ciphertext here. Then once we have the ciphertext coming through, we now get to a point where it has reached the sender. So there has to be what? A decryption process. And this decryption process, again, will be done through the key as an input. And also another input is now the ciphertext. So once they have that at the output, now we get back to where we started, where we now have the plain text coming through to the user who needs to receive it. So it's as simple as that. That is the mechanism. But now when you look at asymmetric encryption, let's look at this process. User A will actually, so let's think of this as user A again, and this one is user B. We'll have user A will obtain the public key. So they'll obtain this public key, and this public key will be belonging to who? To user B. And then the encryption process will start as follows. So the user A will actually use the public key for user B. So they'll use this is user B's public key to encrypt the data that they want to send. Then the input will be the public key for user B as well as the plain text. The encryption process takes place. Then after the encryption process takes place, you now get your ciphertext. And once you get your ciphertext, once it reaches the sender, it is now being transmitted as ciphertext over the network. Once it gets to the receiver, the decryption process is now a bit different from the symmetric encryption. You realize that once the user B receives, they'll actually decrypt the data using their private key, which is they don't share with anyone else. They're the only ones who keep those keys safely and privately. That is why you realize anytime you generate, let's say, a public and a private key using OpenSSH, or so that you are using it to secure maybe a cloud instance or a compute instance over the network that is in the cloud, and you're trying to access it, you'll be told to ensure that you secure the private key from the permissions to where it is actually stored. There's even some mechanisms that have been put into place to ensure that the permissions are in the right number. So for example, if you don't understand file permissions, make sure you check, especially Linux file permissions, and how to use commands such as, it's called what, chmod, right? So make sure you try to understand that and see how, because the private key is actually the alpha and omega in an asymmetric encryption process. So it is the private key that will result into user B getting the plain text. Oh yeah, so Grant, thanks for that. AD now is now BCE. So you usually have now BCE and CE. Nice. So if you look at the strengths and the weaknesses of the two encryption mechanisms, so let's see here. We have the strength for symmetric encryption is it's usually very, very fast. But for asymmetric, it is what? It is a bit slow. So the strength in symmetric encryption is actually a weakness when you come to this other side of asymmetric encryption, because you realize that the encryption and decryption process, they are actually speed sensitive. So it means that it really depends a lot, and also it depends also on this actually comes up with something like a system overhead. The good thing with asymmetric encryption, there is high security for keys. But now with symmetric encryption, since we are sharing one key between the sender and the receiver, the security of how you transmit that shared key, that symmetric key, now becomes its weakness, because the moment it is retrieved, that transmission process is no longer secure, such that no one is. Yes, Evans, Chmod and also T1. Okay, so remember that public key cryptography, that is the one that uses PK. Usually also have another concept called the public key infrastructure, is suitable for encrypting sensitive information, such as keys and identities, to provide higher security. So remember that attackers cannot use one key in a key pair to figure out the other key, because the data encrypted by a public key can only be decrypted by the private key of the same user. So, but the other thing is that it takes a bit of a longer time for public key cryptography to encrypt a very large amount of data, and encrypted packets become a bit large for the and actually consume bandwidth. And bandwidth is a scarce resource in a network transmission process. When you look at the different technologies that are there, even if you're still having fiber optic, still having that issue. So if there's any question at any one point in time, you can post it in the chat, or you can just mute and ask if you have a question. So let's look at what we call the concept of the digital envelope. So a digital envelope usually contains a symmetric key encrypted using the peer's public key. So when receiving a digital envelope, the receiver uses its own private key to decrypt the digital envelope and obtains the symmetric key. So to deal with the issue of transmission of keys, that is a weakness in symmetric encryption, we now have the concept of the digital envelope. And when you look at this, you realize that it's just the same way you get when you get a package from, let's say, your favorite e-commerce. Which is your favorite? Moshi is asking, what exactly are these keys? Okay, they are not literal keys, like the same keys that, yes, that you use to open your house, but they are, what can I say? Who can give me the best word to use? Mm-hmm. Can we say algorithms at Chariot? Algorithms. Because algorithms are the ones that will result in us having the key, right? So we cannot call them algorithms. I was about to say algorithms too, but I realized, yeah, you can call them tokens, yes, cyberops. You can call it a security card. Yeah, that is in literal terms. I'm trying to see if you are having a key as a file you have downloaded, for example, like a .pem file, how will you call it? And I think so yeah, like a digital kind of a password in the form of a file. Think of it like that. Yes, Sharon, you said it very well. A way, a gift, you also said a way of locking your information so that even if someone downloads it without key, they get only letters or something that is just meaningless to them. Maureen is saying that how does the symmetric transmit keys yet they are the keys? How does the symmetric transmit the keys yet they are the keys? So let me just take you a bit back. So this is where we were. So we already said that they are going to be having these key, and it's like one is a duplicate of the other, right? They are going to negotiate. They are going to agree. Now this is the key that you're going to be using for encryption and decryption. So once you agree, it's just like you start dating and you are so happy and in love, you decide to, and you only have the padlock that you bought or it was bought by your parents, so only one key, or you got it from home. So you decide, okay, you're going to be sharing that key. And since you may be having maybe, let's say, classes or maybe work at different points in time, you say, okay, let's go and go to somebody who duplicates keys. We get we get a copy of the key so that you'll one stays with the other key, the other one stays with the other key, so that anytime somebody would want to access the house, since we are having a similar key for the house, it will open, because the padlock will not say that, no, these are copy, and I'm not going to open up until I get the original. So you can see Frederick is saying you recommend someone watching what called the Imitation Game movie to learn or rather understand. Maybe you can share the link to it so that people know which one that is. So we also have seeing the best you see is the Enigma. Yes, the Enigma cipher machine that was used in World War II. So keys are like creating a code between you and somebody that only you two understand. That is Evans saying. You can pass information between each other without someone realizing that they heard you speaking. Yeah. I remember we used to have these small things when you were kids. We used to have a cup. Then we could create a hole between the cup, in the middle of the cup, put a string, and try to talk and see whether we can hear each other. I don't know that you used to do that. So think of symmetric like something like that. You have to have an agreed way. So the issue that somebody was asking, I think it was, I don't know whether it was Maureen, that you're asking. You're asking about how do they transmit, or what did I see? Let me see. How do they transmit the keys? And that is what I was saying about the digital envelope. Think of it that we are talking about now is people are actually sharing their favorite e-commerce platforms, the Amazons, the Jumia, the Kilimall. You realize that the moment you make an order, do they really bring that item to you plain, kavu kavu, if I could say? Like you saw a very good shoe, or a very good t-shirt. Then when you get to where you're supposed to collect it, you find even the person who you are supposed to collect from has already worn it and says, inaonekana itakutosha. So shika. You don't get it like that, right? You find it, yeah, it will actually be very weird. I think I wouldn't even allow that. Asema, hey, and you have put your sweat on it, and you want me to pick it up. So and the other thing you'll also do, apart from seeing that it is in a package, you'll be very sure and try to check that that package has not been opened by that. For example, if it's a post office, or it's a G4S, or a Wells Fargo, whichever way you receive your packages, you'll be keen to check that it has not been tampered from the way the guys from, let's say, Jumia had packaged it, right? So so you realize that that is the same concept of the digital envelopes, right? The symmetric key will now be encrypted using the public key of the receiver. The private key of the receiver will be used by the receiver to decrypt that digital envelope and get the symmetric key, and now use it to now decrypt the data. So let's look at this process so that we understand it. So
That's 50.
let me just sort this and okay, good. I think I've sorted that out. So what was I saying? So let's look at this. So take note of the numbers 1, 2, 3. We are getting up to 10. So what is happening in step 1? Somebody can tell me. We are going to do this together. I'm not going to explain everything so that it is a bit engaging, right? So what is happening at 1? Somebody can tell us in one word. Don't write paragraphs. Don't write a love letter. You know it's Friday, so and you really need to write this. Yes, the first thing is that the plain text is now being fed into an encryption process. And also the second in number 2 is that also the symmetric key is also being fed into this encryption process. That is the plain text and the symmetric key, so that we can come up with what is happening, what is coming out, so that we get in 3. What is coming out of in 3? Yes, Phyllis, ciphertext. Yes, all of you, you're correct. All of you are on point. I see you're getting this. So look at what happens. When you get to 3, we don't go to 4. Here, there's no 4 here, right? This is 7. So you're not coming here first. We are going where? We are going here. So let me just clear that so that it doesn't look look dirty. So we are going to the 4th. So what is happening in 4? So we are having another process that is taking place. Almost now the transmission has started, right? For the ciphertext. So in 4, what you're having, we're having now the symmetric key. We want to ensure that we securely transmit that symmetric key to the receiver, so that they can also use that symmetric key to decrypt the plain text that was there in 1. So what is happening in 4 and 5? The encryption of what? Somebody can put it in a phrase. I know that can't happen in one word. What is happening in 4, 5, and 6? What is happening to the symmetric key, Brian? Yes, so the encryption, they are encrypting the symmetric key with the public key of who? User B. Let me write user A and user B here so that somebody can be able to see what we really mean. So you come to realize that this is a prerequisite process, because without it, when the ciphertext gets to, is the ciphertext, right? This one. When the ciphertext gets to user B and they don't have the symmetric key, they'll not be able to do anything with that ciphertext. Yes, Jerry, a bit of a combination, some mathematical way. So what happens here? After we are now doing what? We get to 6. What is, we call this a ciphertext. What is this? What is that? Yes, Brian. It's the digital, it's the digital envelope itself. And it has been generated after you encrypt the symmetric key using the receiver's public key. So the digital envelope is the one that is now transmitted also to the user. Then what happens is there's a decryption process that takes place. There are 2 decryption processes that are going to take place at the same case. There's been 2 encryption processes, this one and this one. They're also going to be 2 decryption processes, this one and that one. And what happens here is we are having, so we have gotten to, and realize this, we now, once we finish up to step 6, step 7 is where you are now having the digital envelope is also being sent together with the ciphertext in that 7th step. So in the 8th step, it is the decryption of what? The symmetric key. So Mkiribosi, you're not understanding. Is it being done twice? No. What is happening? Let me just clear this ink. I'll not start from the start. I can't start from the start. Okay, I can start from the beginning, or the beginning of things. So this is the normal symmetric key encryption process, right? But we want to assure people that we are not transmitting the symmetric key anyhowly. So what do? We have another parallel process of ensuring that we are going to have a secure transmission of the symmetric key. So this is an encryption process that relates to the symmetric key. This is an encryption process and a decryption process that relates to the plain text. I hope you are now getting it, Mukiribosi. So we are now at step 8. We have now used as the user has received the digital envelope. They decrypt it using their own private key. Now they get the output in 9 is what? What is the output in 9? What is the output in 9? What is the output? What are you getting out of in 9? That is now the input. Yes, it is the symmetric key. Yes, it is now this key that has now come back. Now, because it was being transmitted securely, you have now gotten it back. It is the Jumia package. It's that good t-shirt or that shoe that you wanted. Now you have opened the package, but I don't know why. I don't know whether you usually get this, but you're going to talk about it. Whatever you see is usually rarely what you get. I don't know why. So, but in cryptography, it has to be exactly the same thing that you ordered is what you get. So if there's somebody who works there, or is, I usually see all of you say you are Jumia agents, blah blah blah. So there's a time there are so many advertising things all over. Yeah, so the symmetric key is the input to the decryption process of the ciphertext, and then we get now the plain text going through to the user. So that is the process of the digital envelope. So what happens? There's also another thing that we need to do, another process which we call data verification. And when we talk about data verification, who has an idea? How can we verify that surely, because I've asked you that question, how do we ensure that the symmetric key that we get out of that decryption process is basically the same as what we really want, as is the same that the sender wanted? How? Hash value, yes, Major, you're correct. Maurice, I can see Sharon, you're saying cryptography is the art of transforming intelligent message into an intelligent message, and vice versa, using a cipher and a key. Cipher is an algorithm for transforming intelligent message into an intelligence by transposition, and ciphertext is the transformed message, and key is like the digital password. If you can bookmark something, copy that into some place. If you really, somebody ever asks you what cryptography is, Sharon has already put it in one word, in one phrase for you. That is very good. You can also do CRC, yes, chariot, cyclic redundancy check. That is correct. So let's look at this process. I'll not go through it in a lot of detail that I've done the other side, but remember it's almost similar. So we have the plain text. We have the plain text here. The first thing that happens to the plain text is what? Look at one. The encryption of the plain text using the receiver's public key. So you have user A, you also have user B here. So once that has happened, the whole process is going on. This is the ciphertext. It has been transmitted securely. It reaches the receiver. The receiver uses their own private key. Let's ignore the numbers first. And then a decryption process has occurred, right? But let's see. So after it is being transmitted, the same plain text is also sent through a hash function. So what are the different hash algorithms that are there? Which ones are they? I believe you guys are very, I think this is just a refresher for you. There's SHA, there's MD5, yes, Mushi, there's SHA. And SHA, I think SHA has different variations, right? Same case to MD. MD, what does MD stand for those who know? What does SHA stand for? What do they stand for? Yes, chariot. MD stands for message digest. What about SHA? Secure what? Secure hash algorithm. Yes, secure hash algorithm. It's very important to know these things. Somebody can be asking, Aliman can simply ask you, what does that MD stand for? Then you start, I have a good one. I don't know whether it's a hashing, but it's an algorithm for security. What does RSA stand for? Yeah, I'll catch people. And don't Google. If you don't know, okay, I know you'll Google and post it there, but give me the names, Major. I want the names. Who are the founders? Who and who? Are they 3 people or 1? There are 3 of them. Who are who and who? Or you'll bite your tongue trying to type them. But I think your tongue is not involved. You just know they are Indian. They are kind of Indian somehow. Anyway, somebody who has Googled already can post for us, but don't make me try to announce, or maybe, to pronounce. Is your net that slow? Should have already gotten that. I'm waiting for it, then you go on. Yes, Rivest, Shamia, and Adelman. So I don't know I don't know whether some of you knew that RSA stands for some three guys who sat down. How many of you can sit down and come up with something? Then we say, let's say Mushiri. I think if you say Mushiri, I've already mentioned M there. Kenya and which ones? Evans. Then you say MKE algorithm. And somebody asks you, says it's Mushiri, Kenya, and let's not use Evans. Let's use Cheruyot. All those are Kenyan. Okay, let's say Kenyan kind of names. Mushiri, Kenya, Cheruyot, MKC. Anyway, you'll say that you wish maybe if they'd not been invented, maybe you'd have been in the mix. Anyways, think about it. Think about it. I've seen people in Kenya. In Kenya? How do people who have businesses do it? I saw another one the other day. They put the first two letters of the name of the husband, the wife, and the kid, and you have to struggle dealing with that. Anyways, the Kamau and Sons, yes, and what? And who are those sons? Sons. Anyway, let me not get off track. Let me not get off track. It's Friday and it is very easy. You can easily get off track. Kidogo tu and you're out there. So let's go on with this. So what is happening? Jamesha. So what happens when they break up? So if it was the ladies, it remains to be Sha. Or what? Anyways. Okay. Liquidation. Then you start another one. Yes, yes. It bites each other. Maureen. Let's go on. So where were we? Packet received. So we are so we were there. Well, we are actually in 5, right? So the plain text is going through the hashing function so that we're going to get a hash value, right? So then again, also now that hash is encrypted using the user A's private key. Then that is what we term as the digital signature, is the concept of the digital signature that we're talking about. Then once it reaches the receiver, that is user B, they'll decrypt that digital signature using the sender's public key. Then they get the hash value. Then once they do the decryption process here at the top, they'll compare that the hash value that was here, that was generated from here, and the hash value that was here to confirm the integrity. I don't know how many of you have ever done that. Ama you just download and install things. I usually used to see somewhere when I'm about to download certain software, especially ISO files, maybe, and some, especially those regarded in security. Usually see them, they usually gave us the hash value. For example, like this, the MD5 or the SHA value for this file. But I never used to say, okay, can I just ensure that after I downloaded, I do some hash comparison and I confirm before I start installing. I don't know how many of you have ever done that for software. If you do that, I salute your level of distrust in this world. Kenya, yes. Tails image, I salute you. I think that is good. Unless I think maybe I only wish that is usually automated. But personally, me doing it, I think it's rare. Yes, Samuel, you also haven't done it. It's quite something. It's quite something. There's one time I ever tried to do it, then I saw that it has to it has to, I have to wait for some minutes, and I said life is too short for me to start waiting for it to generate and to do those kind of things. So I only wait. I hope. Yes, yes, Rose. If bad, bad. So let's go on. I hope you've understood this process of the digital signature. Yes, gift. If the computer really crashes, then you're told to verify, and you've already lost your data. You really wonder what can do. So some of the algorithms that are there. So you have RC4. You'll be telling me what the RC stands for. What does RC4 stand for? So we have what we call stream cipher and block cipher. There's some, one works in terms of, okay, let me just be so blunt. Some uses what we call a continuous stream of elements. Think of it like when you're streaming movies. And then plain text, block algorithms or block ciphers. They think of it like when you first, instead of streaming a movie from Netflix, you download it as a block first. Then you now start watching it. So you download a number of movies. So think about block like that. That manner. So what does, yes, torrent download software do the hash checks for you? That's a good thing, baby. That is why I think most of the time, although some people usually think that anytime you're downloading something through a torrent, you might be hacked, but it's usually not the case. Torrent is still good. Yes, thank you, Maureen, for checking that out for us. Reversed, and reversed. This reversed guy must be very, very rich, right? Evans, this page might appear in the exam. Okay. Okay, we'll talk about the exam at that point in time. We'll do it after the first break. So let me not talk about exams. If we start, I'll do a data which I don't want. So we have DES. DES stands for, there's triple DES, which is actually, I remember when I was, yes, stands for data encryption standard. I remember when I was in campus, we used to, when you're doing our computer science and we did a unit on cryptography, we actually had to draw diagrams and also do the calculations. And I think the worst, which one was that one? I don't know if it was DES. We used to even do a question that you take an algorithm, you actually have to draw some tables and crazy stuff. I don't know whether for those who are in the final year, they're doing computer science, you're doing those things. I think AES stands for Advanced Encryption Standard. I have personally never used it, but I've never personally had to actually manually encrypt data using math by calculating and do those things, but to do it that way in an exam scenario, you can imagine if you miss something. And I think it was quite a thing. So we also have another block cipher called IDEA. What does IDEA stand for? So we also have RC2, HR variations, RC5, RC6, International Data Encryption Algorithm. Thank you, Major, for that. We also have SM1 and SM4. SM stands for? What does SM stand for? Anyone has an idea? As you look for that, you can be moving on to the asymmetric. Those are the symmetric. The asymmetric is DH. The only thing that comes to mind when I see DH is dining hall. I don't know what comes in mind for you. Then RSA and DSA. So you already been told RSA stands for reversed, Shamir, and Adelman. So I don't know whether Adelman cheated on Rivest and Shamir, or Shamir and Adelman cheated on Rivest and had something with somebody with a name with D, starting with D, or what happened in asymmetric? Who can tell us? So DH stands for Diffie-Hellman, right? And the other one is, we already said Ron Rivest, Adi Shamir, and Len Adelman. Then DSA is digital signature algorithm, right? Yes. So those are the asymmetric. So in terms of hash algorithms, they're the ones that we used for the digital signature. We have the MDA, usually just called MD, message digest. We have secure hash algorithm, which is very, very popular. Then we also have senior middle tree. All these, and remember that hash algorithm are one way. You cannot understand or make out the data that was being hashed from the hash value. I believe you already know that. So SM3 is a commercial algorithm, senior middle tree, which was compiled by the China's National Password Administration. That is why I think I was not even. And they have a longer key than SHA-1, and they are very difficult to crack, and therefore they are a bit more secure. Yes, SHA-1 is a bit less secure in terms of hashing and everything. So I think that is why people like in China, they came up with this. And that is why I think we have SHA-2. We don't have just SHA-1, we have SHA-1, SHA-2, and also SHA-3. So let's go to the quiz. Which of the following items are symmetric cryptography algorithms? Symmetric cryptography algorithms. Which are they? So you already know MD5 is not, because MD5 is what? MD5 is what? Somebody says yes, MD5 is a hash algorithm, Rose. So what about RSA? RSA is a what? RSA is asymmetric, right? So obviously it now leaves us with data encryption standard, and then the advanced encryption standard. So it becomes that the ones that are symmetric, and always remember that if you're doing any kind of quiz or exam, told item, just don't find one, then you go on and you say, the answer is C, and you go on to the next one. Make sure you look, because all of them are, the two of them are both. Yeah, so the one saying D alone, the ones who are saying C alone, it is both DES and AES. Then we also have the second question, which of the following algorithms is used by digital envelopes? Which of the following? Is it symmetric? Is it asymmetric? Is it hash? Or is it all of them? Or is it some two of them? You can see most of you are saying A, asymmetric, asymmetric. I can see Jerry are a bit different, and also Joe. You can see Cybops, you're also saying two. So don't forget, if you're, again, as I was saying, when you look at it, let me just jump to where we were. We were being asked about what? Digital envelope, right? What were you being asked? Hata nimesahau. I think it was, sorry. We're talking about digital envelopes, yes. So if you're being asked about digital envelopes, and you remember the diagram, this one, you'll see that we have the process of symmetric encryption or symmetric algorithms, because you're having this symmetric key. And then you also have the process of asymmetric encryption because of the public key and the private key that is happening. So you can see there are two algorithms that are being used there. So I hope that is very clear. So don't forget and always understand these kind of things, because they are trick questions. The moment you just say A alone, you have already missed the mark. The moment you say B alone, you've missed the mark. Obviously, I don't know what will be in your mind for you to say it is C. Yet we've spent some time there. So we've looked at the differences. So yes, the answer is A and B. Yeah, so they are used because you cannot say it is only one. For digital envelopes, they actually use both. So what are the differences between symmetric and asymmetric cryptography algorithms? So we have, that is what we've looked at. We've been able to know the mechanism of digital envelopes. We saw what digital signatures do so that they help in verifying that whatever is received is of what was actually sent. We looked at some of the common symmetric cryptography algorithms. Here we talked about which ones are they? Remember them? RC4, the DES, the triple DES, the AES, IDA, RC2, RC5, RC6, and SM1 and SM4. The asymmetric, we've also seen that it is the Diffie-Hellman, RSA, and also the data, what? The DSA, right? Digital signature algorithm, right? Yes, Bryant, digital signature, when you look at digital signature, what is being used? We already can, the moment you see public and private key, just know that is asymmetric, right? It uses that, right? Here, it also uses another algorithm to do hashing, right? To create the digital signature. So if you're being asked for digital signature, not digital envelope, that is where you can now say there is the use of the asymmetric and the hash algorithm. Kiko sawa. That is fine. So hash we already said is MD5, SHA, and SM3. Good. I think that counts it as that for that slide. Let's move. Let's see whether I can do one more in module 4, then we go to module 5. Then, then I'll also share the attendance during the break. So this is the public key infrastructure certificate system. Remember, when you're looking at something like HTTPS, there's usually what we also have the PKI. You also realize, I think Kenya is also in the process. They were in the process of coming up with its own PKI. I don't know whether you followed it up on that, but it's something that you can check on. So you'll be able to describe the PKI certificate system architecture and also master the implementation of the PKI certificate system. So in a PKI public key infrastructure, we also have what we call a digital certificate. We also have a system structure, and also we have the implementation. Yeah, I'll not take too much time like that. And the other one I wanted you to understand because they are so fundamental processes, and you can see. So in a digital certificate, and this is also used, for example, when also you are having these credentials. Let's say when you also get maybe a certification, they can use the PKI and also have a digital certificate for you that can be authenticated. I think also Kenya is in the process of trying to ensure that even something like you cannot forge the KCSC and the KCP and something like that. So something that is also in the pipeline, but it is something that is already being used in other application areas. So you can think of a digital certificate like an ID, right? An ID or a passport. So the moment you show it, it means that, oh, I know now you are the one, you're actually the one. So you can have a self-signed certificate. You can have a CA certificate. Usually have what also are called a local certificate. And even another type is a local device certificate. So the CA certificate is usually owned by the certificate authority. So, and most of the time you'll be able to see exactly. So for KRA clearance certificate, they just check the numbers through exactly. Yes, usually do that so that there's some way of authentifying, verifying the authenticity of that certificate there. And even the system itself that KRA uses, the iTax portal, has a lot of usage of what we call the digital certificates. So if you want to know more about this, I think it's also in your document, so you'll get to see that more. So how does it really look like? A digital certificate usually looks like this. It has a version, a serial number, a signature algorithm, it has an issuer, it has validity, it has the subject name, the subject public info, extension, signature, and you realize that it is also encrypted. It is actually encrypted with the private key of the certificate authority. All of these, and then what we get is that encryption, for example, the digest that we get after hashing is what we have called the signature. You already know that a digital signature is generated after you encrypt, after you hash whatever is come out as an encryption of all these metadata from a digital certificate. So it usually includes a public key, name, and digital signature of the CA. So how does a certificate look like? There are usually three formats. They usually have a PKCS, which can save certificates with or without private keys. DER usually saves for certificates without private keys in binary format. The common extensions are .der, .cr, and .crt. I believe you've ever seen .crt somewhere. We have PM, usually saves certificates in .pm, .cr, and .crt. Don't know whether I have one of the certificates usually used for our website. Let me see whether I have it here. I can show you how it looks like. Yes, I have it. So you can see, I don't know whether you can see something here. So you can see I have some certificates for our site that we usually use somehow. So we have, for example, these are PEM, you can see a .crt. Which other file type are you seeing here? You can see the .pfx, right? You can also see .cer, and .cer is also part. And you can see they are different, and you can see some have even been identified by Windows. These are security certificate. These are personal information exchange, something of that sort. So those are usually very important, especially in the process of showing that a site is secure. So it is applicable, it is usually there. It is very important to know where do you put which kind of certificate, or which ones are you supposed to securely store. So what does it look like? So usually have a user has the plain text. So data between the user may be stolen and altered by user, i.e. by the user C on the internet. What does it do? Is encryption. We've already looked at this a bit. Symmetric cryptography. And then we also do another. So before communication start, a key distribution method needs to be determined. So this what we had, the digital envelope. Then user C intercept the data from user A and B. But what does they realize? That user B encrypts the forged information with its own symmetric key, encrypts the symmetric key with user's B public key, and sends the encrypted key ciphertext. User B decrypts the ciphertext and considers the data sent as user A. So this is the problem that it can be occur. So what happens? User C. So these are some of the problems that can occur at any stage. You can see encryption is time consuming and encrypted data becomes lengthy. Although the encrypted data can be fragmented easily, it is difficult to transmit. So these are some of the problems in each and every part of the process, that the standard process that we've looked at in the other lesson. So in each and every step, you can see there's an issue somewhere. There's an issue, 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 there's an issue. So so this brings out the necessity of the PKI, public key infrastructure. So it provides some certificate management for compliance with certain standards, and it is a basis for e-commerce and the core of what we call information security. And why do we say that? So it usually consists of an end entity, a CA, a registration authority, and also what we call a certificate revocation list. So this is how it really moves around. For the interest of time, I cannot go through the whole process, but know it consists of all these. Then in terms of the life cycle, so the entire life cycle of local certificates, including the application, it includes an application process, an issue process, a storage process, like at the point an activity. Then after that, download is done, installation is done, authentication is done. There's also renewal. Certificates usually also expire, and also sometimes they can also be at the end of it all revoked. So all this is now explained in that stage, and how is it implemented. So there's a process here, there's a working process. For example, how does it? There's usually an authentication center. The first thing is a request the CA certificate, and also this one request the CA. The CA certificate is provided. Then they are returned in the second. That stage install. Also, this one installs independently. Then send public key and entity information to apply for local certificate. They send the public key and entity information to apply for a local certificate. Then after verification is passed, they are also given their own local certificates to install independently. They install the local certificate. Then they obtain the local certificate from each other, right? Then they verify the peer local certificate. Then now communication can take place. And this is what usually happens, if, for example, in a PKI network. And it is much more efficient than the standard, this kind of process that we had here. Because if you do it this way, without a PKI, you'll not even be able to communicate. Using M-Pesa's public key to encrypt the password has always been a challenge to me. Evans, that is what Evans is saying. I guess I'll have to rethink after this, right? Yes, it's very important to know. And sometimes there's a time even M-Pesa had quite a process for you to be able to log into their platform. You have to install certain certificates onto your local machine. And sometimes those certificates, if they expire, you lose access to your login. I think they have changed that a bit. I remember there was a time I was trying to do that process and it was quite something. Yeah, and you had to use only Internet Explorer. Yes, that is true. It was crazy because you never know when it will expire, and sometimes you'll not know because since it's a local certificate, it will not notify you when. I think they used to say it changes every week, or I don't know what happened. I think it became so untenable to be telling people every week, come download this new certificate so that you install it in your machine and do that whole process all over again. So I think they changed. It still exists for their API. I don't know. API. Okay, I've done a bit. I've used the Raja, but I don't remember doing that when I was logging in. I think these days, I think they have a user and a password. Yes. Yeah, they changed it, right? Yeah. I think there's an M-Pesa organization portal or something. You go there and set things up and yeah, they changed it. Yes, yes, Felix. Yeah, they changed it. So it was crazy. I remember, I think I gave up. I think when I was starting out and I was so eager to learn about how to set up uh, payments of M-Pesa on clients' websites. They gave me some bit of character development and made me rethink. They made me rethink life and made me feel that I never did anything in campus. So they also have what we call IPsec VPN. VPNs are also very important in secure communication, and also they work together with the PKI. So the details around it are also available on your slides. I'll not go deep into it. There's also another variation of VPN called the SSL. So it is through the VPN that you now exchange the certificates. So it helps in exchange of the certificates. You can see here, usually very helpful. So let's go to the quiz. Nice. At least today's slides are not that long on me. So which of the following is not a certificate format supported by USG 6000 series firewalls? So this is just a trick question because I don't think there's a certificate that has a format of TXT. I don't remember teaching that. So the answer is obviously D. Then what about the second question? That is obvious. Thanks so much, everyone. Was answered. Yes, I can see all of you. Mushiri, Mwangi, Julius, Nicholas, Kemboy, Rose, Mukiri, Bosi, Phyllis, Kefa, all of you. You guys should always be. I wish I could meet you physically and be having a class with you. You look like a very interesting class. Katiko, you're very interesting. Can imagine how it would have been. But I'm usually very tough in person. I usually don't joke a lot like I do in online. Then what does yes, I have to be tough because if I don't look tough, I'll look like I'm the class rep instead of the lecturer. So what does a PKI system consist of? It consists of what? I've already mentioned, and you can look at it. Let's go back there before you jump into the answer. Geoffrey, you decided we enjoy. Geoffrey. Is it Sabbath already? Anyway, let's go on. Wow. Oh, wow. Wow, wow. Wait, I even wanted to look for the slide. I got confused. Where was I? Well, it typically consists of what? I think this is where we started, the system structure. So here it consists of the end entity, the CA, the registration authority, and the CRL database, the certificate and the certificate revocation list database. So let's look at what is in the question. So what does it consist of? The end entity, the certificate authority, yeah, the registration authority. Yeah, I think all of them, right? Yeah, yeah. I was actually doubtful of their registration authority, but I've seen it is there. So it is all of them. Okay. I think that takes us to the break, all right? I think it's already 45, 4:45. Let me pause so that I wish now we can listen to the Sabbath and anything, but I can see we also have others in other religions, so we don't need to do that. So let me pause the recording so that we'll resume it so that it's not too long. It will remind me to resume it after the session, after the break. And pause it. Okay. Recording is back. Thank you. So as I was saying, let me share my screen. There's a number of things that, one slide that I not looked at in module 4, but I'll just brush through it. It's called application of cryptographic technologies. So as I was mentioning, it is mainly used some of the times in different scenarios, as well as some of the VPN technologies. So when talking about the application of cryptography, we already understood the matter of the digital envelope, the digital signature, as well as the digital certificate. So the digital envelope ensures confidentiality. Digital signature is for integrity. And most of the time, the digital certificate is now for what? Non-repudiation. Non-repudiation is what? Somebody not denying that they received or they're the ones who sent some information. Also, digital signatures, all these, the three, can be applied to VPN. I've talked about IPv6 because, IPv6 came in to solve the issues that were coming with regards to the exhaustion of public IP addresses in IPv4. We have HTTPS login. You already know that HTTPS uses these concepts. Then also system login authorization, such as SSH login, is also takes advantage about this. So I don't have to define what a VPN is. I believe all of you already have an idea because you've tried to use VPN for a number of things, for security, for trying to access data without paying for bundles, a number of things. So how do we categorize? We have as SSL VPN that works within the transport. We also have a layer 3 VPNs. Within the, yeah, exactly. And then we have within the network, usually have the network layer, the GRE and the IPsec VPNs. The data link usually have the PPTP, L2F, as well as L2TP. If you want to more details of it, So most of the time you have point-to-point tunneling protocol. You have layer 2 forwarding protocol. You have layer 2 tunneling protocol. All these are there within layer 2. Another thing is on some of the applications of scenarios of VPNs is site-to-site VPNs, which is a connection between two LANs. This is usually mostly used, especially when people are working from home and they have to securely access enterprise resources that are there within the premise. Usually have that. You also have, especially I think when talking about branch, a branch and headquarter, site-to-site works best. Then you have now the client to site when somebody is working from home. So that is the difference. So take note that that is what. So more details are there, the layer 2 tunneling protocols, how it works, the details around it. We also have the GRE packet handling process is also here. Some of the security policies around it. We also have the IPsec VPNs. You can look at that. Also the protocol framework of IPsec. Also IPsec Security Association is also here in in a lot of detail. We also have encapsulation in transport mode, which is also here. In tunnel mode, how does it really work? Encapsulation is now where you are adding more items onto the packet, right? So IKE SA also is here. Internet IKE stands for Internet Key Exchange. We also have IPsec encryption and decryption. And I remember I'm telling you that I'm brushing through so that you understand what you need to also go on and cover. Then also we have the SSL VPNs, which now work in the transport layer. So since SSL is a security protocol, it will provide secure connections for TCP-based application layer protocols, right? So so what is not secure? Look at HTTP, the normal HTTP. It looks like that. It goes from HTTP to TCP to IP. But what about looking at it in a secure way? HTTP, then SSL. SSL stands for Secure Sockets Layer, right? So HTTP, then SSL, then TCP, then IP. Now that is where you usually have the HTTPS. So we have some, like for example, like a USG series device. These are Huawei. Then you also have the security access gateway, SVN. All these they can help you with regards to file sharing, user authentication, port forwarding, a web proxy, also and as a network extension. So what about the VPN configuration? You can be able to see more what is the application scenario of what do you require? So if, for example, one of the requirements is a company has its own VPN and a VPN gateway, such as a USG firewall deployed at the internet egress. Like that internet egress is where, like, for example, at the exit, right, of the headquarters, right? So you can see this there. For example, this now we can think of it like that. It's okay, Daniel. That's fine. Totally understandable. Then we'll be there. Then let's meet each other somewhere over. Can even meet over coffee or in Java somewhere. So let's go on. So I was thinking about employees on the move need to communicate with the company's internal server through what we call layer 2 tunneling protocol tunnels. So that is some of the application scenarios. So you can look at the configuration procedure there. How does it really function on a firewall? You can be able to see on the web user interface. You can look at the numbers and see how you can do that. How do you set the parameters? You can do this. The good thing is there are good lab scenarios where you can set these up over ANSP and even access that web user interface of that USG firewall image and be able to set these in a simulated fashion. So you can even set up dial up user information You can also set up the VPN client and the authentication, right? So that when somebody, before they are able to access, they can any VPN that any VPN client coming in, they have to be the same. This client settings must be also the same settings on the firewall. So this is also another, this is now application scenario of GRE. That was an application scenario for what? For client initialized L2TP VPN. So there's also an application scenario for GRE. You'll be able to check some of the requirements. It requires 2 subnets, network 1 and network 2. And then you also have now a GRE tunnel that is established across the internet between the 2 firewalls. So the configuration procedure works on that. Some of the things that are mandatory are in that color, right? Blue and orange, and the gray ones are optional, although I'm not seeing any optional. So how do you do it on the web user interface? You can be able to start from the first firewall, the firewall A. You'll be able to click on those steps. Then you do the root configuration in the first firewall. Then you do some verification that the 2 networks can ping each other, and then you can set it up. Then also there's also an application scenario for point-to-point IPsec VPN. You should be able to know what are the requirements from this application scenario, and then you can look at the configuration procedure, like what do you need to do before you so that you can say you have already finished configuring. Then on the web user interface for IPsec VPN configuration, you're also given some bit of steps, as well as also remember that these are some of the things that you need to do for the 2 firewalls for interzone security policies. These are some of the parameters that you need to set to allow network 1 and network 2 to communicate, and also to allow internet key exchange negotiation of packets to pass through for the first IPsec 1, IPsec 2, IPsec 3, and IPsec 4. That is how you do it. That is how you set it up. So on the web user interface, there's also some process there that you're guided on. Then also in terms of configuring encrypted data flows, there's also some steps there. And then how you apply an IPsec policy on the web user interface after the configuration is complete, you also do that. Since I've rushed through, I'll not take you a lot on the quiz, so I'll jump that. Then I'll say that is what we've covered on that. So let me just again take you a bit through the module 5 in a similar fashion. Then we can now discuss and conclude the classes, right? It wouldn't be bad for us to do it that way. So I hope, don't worry, I said it's a rush through. So it's a brush through, not a rush through, sorry. I'm wondering why it is like that, okay. So there's what we call security operations, which is becoming very important. You hear people throw these new words, these new buzzwords, DevSecOps. But really, what is it? What is it? So are you just saying sec for the security, for the sake of it? Like saying sec, okay. Yeah, I was about to write, then I was clicking somewhere else. So are you saying sec for the sake of it? I wanted to write something so that you see how it looks funny, but it's fine. So what is security operations? You already know that we usually have in a company where security is, or in an enterprise where security is very critical, they usually set up what we call a security operations center. So So when security issues are happening a lot of times, some of the security operations cannot just be solved by the devices. So you have to combine the resources, the processes, and even management to ensure that there's secure and stable running of the enterprise devices. For example, a company like Safaricom, like Huawei, which are the communications authority, they wouldn't survive without a security operations center, right? Because they need to ensure that all the infrastructure that they manage are running in a top-notch way. They're not leaving the security just the devices. There's also the combination of the resources, the devices, the people, the management into what we call a security operations. So security operations usually consists of a BCP, business continuing planning, physical security, managing security operations, which all these are some of the activities that usually happens. Then you have the
Kevin,
requirements. Yes.
you're not sharing a screen. I'm supposed to, you are
Oh,
discussing.
I'm not sharing my screen. Don't tell me I've not been sharing my screen all that time.
Yes.
Even since they started.
No, module 4 you shared, and then when we move to module 5 is the one that we'll stop sharing.
Oh, okay. The moment, okay. So when I was talking about IPsec VPN, you are seeing that?
Yes, sure.
Oh, okay. Thank you for telling me that. I was about to say, damn, I'll have to record all that again. I can't survive. Anyway, thank you so much. That is why I love this class. Comes to the rescue. Always comes to the rescue. So I was saying, sorry, I was talking about security operations, right? And as I was saying that it's very critical, and that is where the jobs are. For you who is interested in cybersecurity, for who has invested 15 hours of this week alone on cybersecurity, which I hope you're not going to stop after the classes at the bootcamp ends. You're going to keep that momentum going. The jobs are there in a security operations center, and the demand is not decreasing. It is not diminishing. It is growing. You can even be part of a security operations team remotely, because whatever you have in your mind, how you're able to think about problems and resolve issues in a very timely fashion is what makes you a cut above the rest. So take note of whatever the areas are, because you cannot be a jack of all trades and a master of none. You should be able to have something that you can master. You can be a person who is very specialized on incident response. You can be another person who is also well versed with how we have to call coming up with disaster recovery sites, off-site disaster recovery sites. You can be someone who is very good at forensics. And how can you be good at all those kind of all those kind of areas? The only way you can be good at all those kind of areas is by participating in hands-on activities. Hands-on, what do we talk about hands-on is do a CTF. For example, I think there's a CTF tomorrow. I'm not that person. I'm not that much of a good of a CTF person, but I'm going to participate in it. Why am I going to participate? Because the essence of me participating is for me to learn, okay, these are the kind of challenges that are appearing in the real world scenario. So that even when even when I'm maybe delivering a class, I'll not be speaking out of building castles in the air. I'll be talking about things that I'm aware of, I've experienced myself. And since I might, you might not land a cybersecurity job like that in a snap, but you can easily land a CTF challenge, right? Yes, exactly. Cyber talents. It's that is the one that I'll also be taking part, although in a 50-50 way, because I'll also be having an Atlassian event that I'll be hosting, but I'll still be there. And yeah, so so what am I telling you about is that the only way you can get hands-on in these areas is take advantage of opportunities. You don't even have to wait for a CTF challenge event to occur. We have the Try Hack Me, we have Hack the Box. I think we have a Hack the Box Meetup Kenya group, and all these programs you can see now. I think Huawei has an ICT competition going on, right? And it also has a security track. Take advantage. Don't sit down with knowledge. Don't go down wondering and cramming for exams. Just that. Make yourself a cut above the rest, right? Because the Naivasha will come and go. One CTF event may come and go, but what matters is how much knowledge is it remaining in you? How much is going on in your fingertips? Not the literal fingertips, but the fingertips that you understand. How much can you just resolve in a snap of an eye? So that is what you need to look at. So these are some of the things that you can see. So there's BCP, some of the basic steps if you're interested in about business continuity planning. This was very key, especially when the COVID-19 pandemic struck and there's a whole shift with regards to how people work and the nature of people work. You don't want to lay off people. You can't lay off people because they did not choose the pandemic. The pandemic just came. So you cannot lay them off. But again, you cannot keep them in the office because you're not required to do so. They are not obligated to do so. People are being told to stay at home and you're telling them you want to. So you can see, how do you actually come up with maybe a project scope, a business impact assessment, a continuity planning preparation. And it's not just for the pandemic. There are so many disruptive technologies that are coming into play. For example, in the banking sector, right now we are having all these fintechs. The fintechs came to compete with banks in providing cheap loans, easy loans. I'm sure in the call that we're having right now, the 100, I'm sure there must be one of us who is owing us one fintech some good amount of money, even if it's around 500 or so. So if you are there, you can put it in the chat, although I'll not mention I'll not mention the fintech that you owe money. Maybe they might be having a friend and then they'll be coming on the call and they'll unmute and say, tell us, all of us. Yeah, the good thing is Fuliza will not come for you here. But if you mention another fintech, they might burst out and say, can you bring us our money? You're the one who's talking about going to see somebody in Meru and you are owing us money. So the details are there. You can see there's a bit of more details on it. Then the business impact assessment, the continuity planning preparation. That it has a very nice graphic. You can look at that. You can see what happens there. You can just check. BCP documentation, how does it work? What are the contents? What should it contain? Oh, Vintex, sasa umeharibu kila kitu. But we're going to try to look at it and see if somebody who has it, you can try and see. I can give you some tips around it maybe. Then incident response management. I'm not taking too long. I think I've already said lazima tumalize 45. Saving sangapi? Yeah, 24. So I think I have 20 minutes to go. So incident response management, a disaster recovery plan, you should have that. So think of it. Then we have investigation and forensics, very key. You can hone your skills in that, especially by playing a number of CTFs and don't be a good player of CTFs and you're not having a job. That is joking. You're joking a lot. So you have different types of investigation, criminal investigation, operation type investigation. I don't know why they've used those icons. Civil investigation, regulatory investigation, and also electronic forensics. So that is that. In order to successfully prosecute a crime, sufficient evidence should be provided to prove the crime. So maybe Sharon, you can tell us how much time are you given for that? So that when are you supposed to complete it?
On Monday. And
By Monday.
yeah, if I
So
remember.
you have a lot of time. Is it something that, okay, you're going to, okay, I don't know, I don't know how it looks like. Maybe you can put the link here and then we're going to see. I'm going to give you some tips around it. Just,
Okay.
just tips after I finish the slide. So we'll post the, yes, somebody else wanted to say something?
Mimi nilikuwa nataka tuone cramming powers.
Uh, anyway, let's finish this slide. Nikki, lose my flow of thought. If I lose my flow of thought, it will take me a bit of time to come back here. So when talking about forensics, you have to look at things such as there's some physical evidence, documentary evidence, and even verbal evidence takes place. Have you ever seen somebody, they were recorded, you are in a call with them, and then they recorded you saying something so and so about your boss and something, then they give it out, and the next day you are given a dismissal letter. So all that, and they are part of types of evidence. So investigation and forensic process usually comes with incident confirmation, request for law enforcement, evidence collection and preservation, in-person communication, and filing of lawsuits. And sometimes some of these things that happen, even in criminal circles, I don't know why the digital side of things are not usually looked at a lot, because you hear somebody killed another person, they did this and this. Sometimes the digital trail can give you a clear picture of what happens before that murder took place. So, but you realize, I think the former president launched a well-equipped digital forensic lab, if I'm not wrong, at DCI. So I don't know how much we've utilized it as a country so far since it was launched, but it is something that you can even decide. You can push, especially if your campus is having some specializations in security, and also you can partner up with people in criminology who are taking maybe criminology, and get to request for a field trip to go and see what is there. So what is the difference between business continuity planning and disaster recovery plan? You should know there's a difference. Just check it out and know. But remember, there is one for business. Business continuity is all about ensuring that the business can go on, or business operations can go on in spite of a disaster. And disaster recovery is now trying to ensure that as much as the disaster has happened, how can we get back to the optimal operations that we were? So business continuity is just to ensure that even if we have been hit, still business is going on. Disaster recovery is, yes, we are now hit, we are still continuing, yes, but we need to recover to where we was before. I hope you can see a bit the difference. So that was that. Okay, sorry. I think I'm stopping the share yet. I'm not supposed to stop the share. What I need to stop is the slideshow. Okay. So there's more about the data monitoring and analysis. There's also something about digital forensics, but don't forget, because this is what I'll finish with, is the cybersecurity emergency response. And that will be my final slide before we go to what you have. So I talk about the cybersecurity emergency response. We usually have a SAT team. And did you know that Kenya has one? Kenya has a SAT, or a CC, coordination center. It's usually called what? KE SAT CC or something. So they usually form a core they are the backbone of how to handle cybersecurity incidents. They are not only there within a country, but they can also be there within an organization. So SAS stands for Computer Emergency Response Team, or SAT Coordination Center. So usually have that. We also have some, for example, we had these defense. So it was founded because of the 1989 Morris Worm incident. So they actually had to be tasked, the DAPA, right, Defense Advanced Research Projects Agency, together with the Software Engineering Institute of Carnegie Mellon University, to develop a coordination center to connect experts during security emergency to help prevent future intrusion incidents. So, so they came out also another team called the Forum of Incident Response and Security Teams. In 1990, you can see these are fairly new, 1989, 1990. So emergency response organizations, there are some of them in China. We have SANET, Computer Emergency Response Team. We have the National Computer Network Emergency Response Team Coordination Center of China, SENAT/CC, which just opened. It was recent, was established and became a member of FAST in August 2002, sorry. So you have SENAT/CC. When you look at some of the things, when you look at, there are some of the cybersecurity and laws and regulations that are there within China. How do you classify cybersecurity incidents? So they can be classified as maybe you can have a malicious program, a cyber attack, an information breach, information content. So here I'm talking about that. So you can even have equipment and facility fault, and also and something like a disaster. So they usually have these categories, the warning levels, and also the emergency response level. So you can have an extremely serious incident, a serious incident, a relatively serious incident, and an ordinary incident. So an ordinary incident would result into a blue signal warning, which would only result into a level 4 response. You can see the levels are not there in decreasing fashion as you go up in descending order. And you can see all these yellow signal, right? Warning and a level 3 response. We have an orange signal and a level 2 response, and a red signal, which requires a level 1 response. For example, like there are some attacks, for example, like WannaCry ransomware attack would have actually required mostly a level 1 response. So these are some of the concepts. How does it look like? So remember that the emergency response model works with protection, detection, response, then recovery. That is how it works. It's a cycle, and there's management at all phases. So usually called the protection, this detection, recovery, response model, PDRR. So there are different types of response types. You can have a remote response, which is usually kind of preferred. We have a local emergency response where you have to go there. The team has to be there on site. So what is the process? It is how it goes. If you look at the whole process, that is it is, and this one is what I've told you about. So we have the preparation, you detect, you suppress, you try to resolve the incident, you recover, then you conclude. And you look at it, there are also some activities within it. For example, in preparation, you have to look at what is there, set up the team, create a plan preparation, do security hardening, do assurance, get some assurance, acquire some assurance resources, technical support, and do also some asset risk analysis. When it comes to detection, it's all about routine operation and operation, O&M and monitoring. We have security incident judgment so that you know the impact and the loss, and also to report that incident once you detect. Then try to suppress so that it doesn't go go too far. Think of it like when you've seen somebody has been shot and they are bleeding. You'll try to suppress the bleeding first before you go seek that they go to the hospital. So suppression prevents of the incident spread, suppress it, then you also do suppression monitoring. Then you come to resolving, you get to know where the location is, repair and hardening, then you also do some summary and publicity. So by the time you see an organization has done a public announcement, they must have already gotten to a point where they've done some repair and hardening. Recovery, restoring the configurations, restoring data and systems, backing up all the changes, checking the running status of the devices that recover, and also checking whether the isolation measures are working. So when you're concluding, you realize that you have to come up with reports. You have to come up with an emergency response report, come up with the findings of a security incident investigation, and also you need to look at the emergency response summary, right? That is here. So some of the new trends that are there within cybersecurity emergency response, and if you ever want to work in a CERT, you have to understand all these processes, is that there are some global major security incidents. You can look at some of them that were here. The WannaCry has been talked, the Cambridge Analytica. You remember that whole story, we talked about it early in the week. There are a number of incidents, and all these, your employees need to know them so that they understand the implications of some of these security incidents. So there are some of the new trends is overall innovation, resistance, evaluation, and such. So to finish, which one of the following is not included in the PDRR model? Which one is not included? You can tell me so as we finish. One, the answer is what? Exactly. Management is not part of the PDRR, right? Thank you, Major. Nicholas, Dikip, Dorcas, George, Ian, good. I can see you're listening. Then, which of the following is not a cyber security incident category? Serious incident, special incident, ordinary, relatively serious. You can see some varied answers. I can see Rose saying C. So there's nothing like special, right? Yeah, special is not. So don't forget the question when you're asked. For example, you can see all these questions is not. So always, if you're not very sure, even if you are seeing a certain answer, try to go back to the question and see what you're being asked. And I think that would basically mean it. So with regards to that module, the module 5, which was the last module, the other thing that I would love you to check, considering I haven't gone through it in terms of the slides, is how you do data monitoring and analysis, and also the concept of digital forensics, which is very important in terms of cybersecurity, and usually is tested when you're looking at the certification exam for HCIA security. So I'll finish with this. This is what you call, sorry, what am I dragging to this side? Sorry, I've dragged the wrong thing. So this is, I hope you're seeing my screen still. This is the HCIA security exam outline. So you realize that it's very important to note that the HCIA version 3, this version 3, the exam usually lasts 90 minutes, usually a proctored one, but I believe the one that you're doing is not proctored. Then you have a passing score of 600. You have to ensure that you don't go below 600 when you're doing that exam. So meaning that your chances of passing is very high. Others usually have it at around 700 or 800 over 1,000. You should always note that sometimes there might be some questions that might not be scored, but are there so that they can test whether they can be put in an exam scenario, but you'll not know which ones are not scored. Then in terms of the percentages, you can know where to put more effort. And you can see you should, some of the things that you need to know is application of encryption and decryption takes 20%, security as well as safety operation and analysis, and also the security information and security overview. When we talk about operation system and host security takes the least, and the basis for network security takes the most. So when you're looking at your content, you can see where places to focus, because when you focus on some 3 key areas, right, you can assure you're passing. So I believe even your exam that you're doing, covering these topics. And again, I don't know, maybe you can talk more about this once I get off the record. Is you should be able to get the content, obviously through the training materials, and be able to see what is there. You can see, I already mentioned that I haven't covered much on data monitoring and analysis as well as digital forensics. So it is something that we need to check, but we have already looked at SecOps and also what we call the cybersecurity emergency response. So, and it also covers, usually comes in the exam in a way. So that is the exam outline. It's very important to understand the underlying concepts behind them, because in a work scenario, you're not going to be answering multiple choice questions. You'll be solving cybersecurity incidences, and you will also be, sometimes even the life of people will be at stake when you are doing these kind of things. So I think with that, I'd like to say thank you for coming through for this 5-day cybersecurity bootcamp. And in case of anything, you can still link up, you can still engage, and already know that cybersecurity is an ever-growing field, and the need for cybersecurity experts is constantly growing. So I believe that you continue to take advantage of the knowledge and the concepts that you've gained to build on more knowledge and work on the activities that you've already mentioned, the career perspectives, get to understand cybersecurity is a very wide field. Don't go out there and say you are a cybersecurity expert, because somebody will ask you, where are you in it? And you'll be wondered. So yeah, I'll answer that off the record. Thank you so much, and see me when I see you. Thank you. That was for the record.